To know if something is increasing or decreasing, you have to check the sign of its derivative. So for example, height is increasing if its derivative is positive. So if the derivative, I'll say height prime or derivative of height is greater than 0 or positive. Height is increasing if its derivative is positive. Velocity is decreasing if the derivative of velocity is negative, less than 0. Mr. B's IQ is increasing if the derivative of his IQ is greater than 0. And then smiley face is decreasing if the derivative of the smiley face is less than 0. Again, if a derivative is positive, that means that the original function is increasing. If its derivative is negative, the original function is decreasing. So, recall finding derivatives on a calculator. Find f prime of 3 if f of x is equal to 5 to the exponent sine x. So this is where you open your calculator, turn it on, go to math, go to 8, input the variable, just use x here, input the function 5 exponent sine x, and there is find the derivative at 3. So x is equal to 3 here. So you get negative 1.9996, and you can write either negative 1.999, or if you had negative 2, that's fine as well. All right, is the function already a rate of change? So sometimes f of x just gives you an amount. Like here, f of x is just the bunny population after x years. F prime of x is just, so anytime you see derivative, write the word the rate of change. So the rate of change of f of x, and f of x is the bunny population of the bunny population per year. This one here, if f of x is the rate at which a bunny population increases, which has been bunnies per year, then what is f prime of x? So f of x here is a rate in this case, but the process is still the same. If they want to find the derivative, just write the rate of change. The rate of change of f of x, and f of x is the rate at which a bunny population increases. So f prime of x is just the rate of change of the rate at which a bunny population increases per year, or alternatively, this is the same as per year squared. Because f of x is in bunnies per year, and then you do the derivative, it's going to be per year. Whereas this first one here, you only needed 1 per year. All right, estimating rates of change from a table. You want to estimate p prime of 15. P prime of 15 is right in the middle of 10 and 20, so we can take the average rate of change between these 2 points. P of 20 minus P of 10 over 20 minus 10. P of 20 is 150 minus P of 10, which is 120 over 10. And that gets us 3 people per year, because P's in people, P of T's in people, and the input's here. So 3 people per year. So p prime of 15 was right in between 10 and 20, so that was easy to do. But here, what if they ask us estimate p prime of 20? Which is right here. It's not in between something, it's just right there. You have three different options to do with estimating this derivative. It's like if it's right one of the points, values they give you on the table. The first option you could do is take the average rate of change of between 10 and 30. So you can do p of 30 minus p of 10 over 30 minus 10. And that should get you some answer. You could just take the point right before, p of 20 minus p of 10 over 20 minus 10, whatever that equals to. And alternatively, you can use the two values, well, the value right after it. You could do p of 30 minus p of 20 over 30 minus 20. So again, if they're asking you to estimate the derivative and it's one of the columns in the table, you have these three options to do. You can take the one before and the one after, find the average rate of change, or you can take the point at the 20, use the one before, like we did here, to find the average rate of change, or you could take the 20 and the point after to estimate the rate of change. I'm not going to get these values here just for the sake of time, but you can practice these on your own or go right to the practice.